Hello everyone. With this video we are going to start with a new chapter, that is Heron's formula. Heron's formula is applied to find out the area of a triangle. So we will divide this particular chapter in two parts. In the first part we will be learning about the areas of the triangles of different types, and then also we will learn about the importance of the Heron's formula, the requirement of the Heron's formula. And then in the next part, in the second part, we will be learning what is the Heron's formula and how to apply it to find out the area of the triangle. So here we know that the triangles are classified in two different ways. Number one, according to sides, and number two, according to the angles. This we have learnt in the previous chapters, that is on triangles. According to the sides, we divide the triangles in three forms. Number one is the Scalene triangle, in which all the three sides are different. It means no two sides are equal in length. Number two is Isosceles triangle, in which the two sides of the triangle are equal. And number three, we had Equilateral triangle, in which the length of all the three sides are equal. Then according to the angles, also we divide them in three forms. Number one is acute angle triangle, in which each angle of the triangle is less than 90 degree. That is acute angles. Second is obtuse angle triangle, in which one angle of the triangle is obtuse, that is between 90 degree and 180 degree. And third is the right angle triangle, in which one angle is right angle, or we say 90 degrees. When we talk about finding the area of a triangle, we generally apply the formula, that is half into base into altitude. This also we have discussed in finding the area of different polygons, that is in quadrilaterals, because we know that the area of a parallelogram is given by base into altitude, and hence the area of triangle, the half of the parallelogram, is given by half into base into altitude. Any of the side of the triangle can be considered as the base, but the altitude will be the perpendicular drawn on that particular side from the opposite vertex. So here, if we discuss about the area of a right angle triangle, suppose this is a right angle triangle ABC, in which we find the base of it is A and the altitude is B, because we know that angle B is 90 degree. So this is the base and this is the altitude. Then the area of this triangle will be given by half into base into altitude, and here it is half into BC, BC is the base, into altitude, that is AB. This is half into BC is A and AB is B. We can also write this as half into A into B. So this is the way we can find out the area of the right angle triangle. In case we want to find out the area of an isosceles triangle, we know isosceles triangle means two sides of the triangle are equal. Suppose this is an isosceles triangle ABC. Here AB and AC are equal and each is A. Base is BC and the length of BC is given as B. So here we are finding AB is equal to AC is equal to A and BC is equal to B. Now how to find out the altitude AD? We know in isosceles triangle AD, the altitude also bisects the base, and hence this BD will be B by 2 and also DC will be B by 2. BD is equal to DC is equal to half of B, that is B by 2. Then to find out the altitude, we can make use of any of the triangles, either ADB or ADC. Suppose we use ADC. In triangle ADC, by Pythagoras theorem, we find that AD square is equal to AC square minus BC square. Then what is AC? AC is A. This is A square. BC, that is B by 2 square. And hence it comes as 4A square minus B square upon 4 by taking the LCM is 4. So we have found this as the square of the altitude. It means what will be AD? AD is equal to root of 4A square minus B square upon 2, because the square root of 4 is 2. And hence the area of triangle ABC will be given by half into base. Base is BC into altitude, that is AD. Will that be half into BC's base, that is B. AD we have calculated, this is root of 4A square minus B square upon 2. It means we can say that this is equal to 1 by 4 into B into root of 4A square minus B square. Likewise, we can find out the area of an isosceles triangle. Now we discuss about finding the area of an equilateral triangle. We know equilateral triangle is also known as equiangular triangle. In this, all the three sides are equal. Here we have triangle ABC as an equilateral triangle, and each side is of length x, suppose. Then also we know that altitude in equilateral triangle bisects the base here also, and hence we say that BD is equal to DC will be half of x, that is x by 2. Each side of this, that is AB is equal to BC is equal to AC, is taken as x. Now we have to find out the altitude here also. When we find the altitude in triangle ADB by Pythagoras theorem, we can see that AD square is equal to AB square minus BD square, the same as in isosceles triangle we could find. But here the difference is that AD is x, that is x square. BD is x by 2, so this will be square of x by 2. And hence becomes x square minus x square by 4. Taking LCM 4, this will come as 3x square by 4. It means we are finding that the altitude AD is root 3x by 2. And hence we can find out the area of triangle ABC, that is half into base into altitude. Here base is BC, altitude is AD. Substituting the values we get here half into BC is x into root 3 by 2 into x, which gives us root 3 by 4 into x square. It means we can get the area of the equilateral triangle also by the formula, that is root 3 by 4 into the square of the length of each side. Now we have to discuss the area of a scalene triangle. We know a scalene triangle means no two sides of the triangle are equal. It means all the three sides are different in length. Here we have another triangle ABC. The sides of this BC is given as A, AC is B, and AB is C. Then how to find out the area? As we know that any of the side of the triangle can be taken as base. If we take BC as the base, then altitude will be AD or not? and hence the area of triangle ABC can be found out by half into BC into AD, that is half into A into AD or not. In case we consider AC as the base, AC as base, then altitude will be the perpendicular from B to AC, that will be BE. Then we can say altitude will be BE, and hence the area of triangle ABC, that will be given by half into AC into BE, or we can say this is half into B into BE. In case we consider AB as base, AB as base, then CF, the perpendicular from C to AB, will be considered as the altitude, and hence we say that altitude here will be CF. So the area of triangle ABC, that will be given by half into AB into CF, which can be taken as half into C into CF. And here we are to find out the altitude according to the base in different methods. It's not so easy. This is the reason we want a formula which can be applied to any type of triangle to find out its area. And hence Heron's formula was developed by scientist Heron. This is known as Heron's formula, or also it is known as Heron's formula. We will be discussing in the next video about the Heron's formula, what is Heron's formula, and how to apply it to find out the area of the triangle. It can be applied to find the area of any type of triangle. Let it be any of the 6 triangles. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.